Once in a while, the Ethereum blockchain goes through hard forks. A hard fork is a modification of the rule of Ethereum. How does it affect smart contracts? Are smart contracts always executed with the latest set of rules, or sometimes they're executed with old rules? Let's see how this works. Hey, I'm Julian, and on my channel Eat the Blocks, I teach blockchain development on Ethereum. The current hard fork of Ethereum is called Muir Glacier. The previous hard fork was called Istanbul. So let's assume that I deploy a smart contract in the previous hard fork of Ethereum, Istanbul. When I deploy my smart contract, this is a transaction, and because we are in the Istanbul hard fork, the set of rules of Istanbul will apply for this transaction. After I deploy my smart contract, let's assume that someone else sent a transaction to this smart contract, so because we are still on the Istanbul hard fork, this set of rules will still apply. Makes sense. Now let's assume that we fast forward to the current time after the Muir Glacier hard fork, and another person sent a transaction to my smart contract. How this transaction is going to be processed? Will we use the old rule of Istanbul or the rule of Muir Glacier? Because the current hard fork is Muir Glacier, we're going to use the set of rules of Muir Glacier to process this transaction, even though our smart contract was deployed at a time when the Ethereum version was different. Let's assume that during the Muir Glacier hard fork, one change was to modify the gas cost of some EVM operation. By the way, that's not what happened during this hard fork, but that's just for the sake of explanation. So before the hard fork, that means that executing a function on my smart contract had a certain gas cost, but now it has another gas cost. It can be more expensive or cheaper. Now, what happens if you decide to run an Ethereum node? First, when you start your node, you will need to sync up with all the data from the Ethereum blockchain. Your node is going to process all the historical transactions, and it's going to verify each of them against a certain set of rules. The set of rules that it's going to apply to check each transaction depends on the time the transaction was sent to the Ethereum blockchain. For example, if the transaction was sent during the Frontier version of Ethereum, then the set of rules of Frontier will apply to check the validity of this transaction. So that means that in the code of Ethereum, we must not just override the old rule, but we must still be able to process transaction with previous version of Ethereum. Now, what happened with Solidity? Because Solidity is not included in the Ethereum blockchain. This is something external. Solidity always tries to target the latest version of Ethereum. For example, currently we are at Solidity 0.6.1, so by default this version of Solidity will target the Ethereum Muir Glacier hard fork. But it's actually possible to use Solidity and compile smart contract code for an old version of Ethereum. The only reason why you would do this would be to do some security analysis, but just for the sake of exercise. Let's say that we compile a smart contract for the previous hard fork of Ethereum. What's going to happen when we deploy our smart contract? Well, the transaction will still be processed for the current hard fork of Ethereum. So what matters in this case is not the target of the Solidity compiler, but which hard fork are we currently in. One thing to keep in mind is that all these Ethereum hard fork try to be backward compatible and not break old smart contract. As a smart contract developer, you shouldn't be too afraid of hard fork. It's just that if you deploy a smart contract before, then you won't be able to take advantage of some new features that were introduced in the latest hard forks. If you are curious about how the Ethereum blockchain works, I have a full playlist with other videos on the topic. I'll see you there.